So this is AWS lab number 6, in which we are going to do activity number 8, scale and load balance your architect. So lab overview and objectives are: this lab walks you through the elastic load balancing and auto scaling service to load balance and automatically scale your infrastructure. Elastic load balancing automatically distribute incoming application traffic across multiple Amazon EC2 instances. It enables you to achieve fault tolerance in your application by seamlessly providing the required amount of load balancing capacity needed to route application traffic. Autoscaling help you maintain application availability and allow you to scale your Amazon EC2 instance capacity out or in automatically according to condition you define. You can use autoscaling to help ensure that you are running your desired number of Amazon EC2 instances. Autoscaling can also automatically increase the number of Amazon EC2 instances during demand spike to maintain performance and decrease capacity during lulls to reduce cost. Autoscaling is well suited to applications that have stable demand patterns or that experience hourly, daily, or weekly variability in usage. By the end of this lab, you will also be able to create an Amazon machine image AMI from a running instance, create a load balancer, create a launch template and an auto-scaling group, automatically scale new instances, create Amazon CloudWatch alarm, and monitor performance of your infrastructure. So this is the lab scenario. Before we are starting, we have this infrastructure. We have AWS cloud. In region, we have two availability zones with two public subnet, two private subnet, and with following security groups in each subnet and one NAT gateway. The final stage of the infrastructure, we would have application load balancer, auto scaling group, and two extra security group web instances, and that's all. So let's proceed with task 1, create an AMI for auto scaling. So let's go to EC2 instance, go to instances, so for web server 1, status check is 2 by 2, check passed, if necessary no, we have done it. Select web server 1, and in action tab, choose image and template and then create image. The name of the image is going to be this. Image description is this. Let's choose create image, a confirmation banner display AMI ID. So task 2 is to create a load balancer. In this task, you will first create a target group and then you will create a load balancer that can balance traffic across multiple EC2 instances and availability zone. So in the left navigation pane, choose target group. So in target group analysis, target group defines where to send traffic and that comes into a load balancer. The application load balancer can send traffic to multiple target groups based upon the URL of incoming request, such as having request from mobile apps going to a different set of servers. Your web application will use only one target group. Choose create a target group. Choose instances. Target group name is going to be lab group. Select lab VPC. Choose next. The register target screen appear. Targets are the individual instances that will respond to requests from load balancer. You do not have any web application instances yet, so you can skip this step. Let's create target group. Let's choose load balancer. Create load balancer. Under application load balancer, there are different types of load balancer are displayed. You will be using an application load balancer that operates at the request level, layer 7, routing traffic to targets, EC2 instance, containers, IP addresses, and Lambda functions. Based on the content of the request, let's choose application load balancer create. Name is going to be lab ELB. Network mapping lab VPC. You will now specify which subnet the load balancer should use. The load balancer will be internet facing, so you will select both public subnets. Choose first displayed availability zone. And then select public subnet 1. Choose second and then select public subnet 2. You should now have two subnets selected, public subnet 1 and public subnet 2. In the security groups, choose the security group drop down menu and select web security group. Below the drop down menu, choose cross next to the default, remove it. Okay. The web security group should now be only one that appear. Yes. For the listener, HTTP 80 road set default action to forward to lab group. And let's create load balancer. So the load balancer will show a state of provisioning. Yes, there is no need to wait until it is ready. So task 3 is to create a launch template and an auto scaling group. In this task, you will create a launch template for your auto scaling group. A launch template is a template that an auto scaling group uses to launch EC2 instance. When you create a launch template, you specify information for instances such as the AMI, the instance type, a key pair, a security group. Let's go to launch template, create launch template. Name is going to be lab config. Under auto scaling, select provide guidance to help me set up template that I can use with EC2 auto scaling. In application and OS image, choose my AMI, instance type, t2.micro, and key pair name, VOC key, firewall security group, choose select existing group, and security group, web security group. Scroll down to advanced detail area and expand it. Scroll down to detailed CloudWatch monitoring. Select enable. Note this will allow autoscaling to react quickly to changing utilization. Let's create launch template. In the success dialog, choose lab config launch. From the action menu, choose create autoscale in group. Autoscaling group name is going to be this. Launch template. Confirm that the lab config template you just created is selected. Yes. Choose next. Configure the detail in step 2. Choose instance launch option. VPC is going to be lab VPC availability zone and subnet. Choose private subnet 1 and subnet 2. Choose next. Choose attach to an existing load balancer and lab group. In additional setting pane, enable group metric collection with CloudWatch. This will capture metric at 1 minute intervals, which allow auto-scaling to react quickly to changing usage patterns. Select next. Configure the detail in step 4. Group size, desired capacity 2, minimum capacity 2, max desired capacity 6. This will allow autoscaling to automatically add remove instances, always keeping between 2 and 6 instances running. Under scaling policy, choose target scaling policy. Name is going to be this lab scaling policy. Metric type average CPU utilization and target value is 60. This tells autoscaling to maintain an average CPU utilization across all instances at 60%. Autoscaling will automatically add or remove capacity as required to keep the metric at or close to the specified target value. It adjusts to fluctuation in the metric due to fluctuating load pattern. Choose next. Autoscaling can send a notification when a scaling event takes place. You will use the default settings. Now we are going to add a tag with name and value lab instance. Choose next. Review the detail of your autoscaling group. Your autoscaling group will initially show an instance count of 0, but new instance will be launched to reach the desired count of 2 instances. Let's create autoscaling group. Tag name field cannot have trailing space. So task 4 is verify that load balancing is working. In this task, you will verify that load balancing is working correctly. Let's go to instances. You should see two new instances named lab instance. Yes, these were launched by autoscale. Okay, let's go to target group. Select lab group. Choose the target tab. The two target instances named lab instances should be listed in the target group. Yes. Wait until the status of both instance transition to healthy. Yes. Let's go to load balancer. Go to lab ELB. In the detail pane, copy the DNS name. Open a new web browser and go to this pane. Yes, the application should appear in your browser This indicates that the load balancer received the request and set it to one of the EC2 instance, then passed back the result. Now task 5 is to test autoscaling. You created an autoscaling group with a minimum of 2 instances and maximum of 6 instances. Currently 2 instances are running because the minimum size is 2 and the group is currently not under any load. You will now increase the load to cause autoscaling to add additional instances. Let's go to CloudWatch. In the left navigation pane, choose all alarms. Two alarm will display. Yes. These were created automatically by autoscaling group. They will automatically keep the average CPU load close to 60% while also staying within the limitation of having 2 to 6 instances. Note, please follow these steps only if you do not see the alarm in 60 seconds. No, I can see 2 alarms. Next is choose the OK alarm, which has alarm high in its name. Yes. Return to the browser tab with the web application. Yes. Choose load test beside the AWS logo. This will cause the application to generate high loads. The browser page will automatically refresh so that all instances in autoscaling group will generate load. Do not close this tab. Return to browser tab with CloudWatch console. Yes. Less than 5 minutes, the low alarm should change to OK. And high alarm status should change to in alarm. You can choose refresh. So let's wait for like 5 minutes. Initially, the alarm low was the state was OK. I was waiting for alarm high to change the state in alarm. It changed to in alarm, but now this is showing that insufficient data. I don't know why. So let's proceed. So wait until yeah, this is done. In search box, go to EC2. Instances. Yeah, there are more than 2 instances labeled lab instances that are running. Now task 6 is to terminate web server 1. In this task you will terminate web server 1. In this instance was used to create the Amazon machine instance image used by your autoscaling group, but it is no longer needed. Select web server 1. Instance state and terminate. Successfully initiated termination. So let's submit our work. So we got a total score of 35 out of 35. This means this lab is completed and we have achieved all the objectives. So thank you.